VisualCADCAM 2018 is our latest version of our CAM product, and this is our standalone system, our flagship product. We also have plugins in other CAD systems for Rhino, SolidWorks, for Alibre. We also have a cloud-based product called VisualCAM for Onshape. So what you're looking at is our standalone product called VisualCADCAM, so it doesn't depend on any other host CAD systems. It runs by itself, so you can bring in files in a wide range of file formats, starting from 2D drawings like DXF, DWG. We can work with IJustStep, STLs, Parallel Solids. We support a whole range of file formats in here. So if you go up to the CAD ribbon bar across the top and pick Open, you will see that we have support for a wide range of file formats in here.
Okay.
Okay, so today what we're going to do is, load the file that you had sent us. So I'm just going to go into this folder in here. You see that I have your DXF file in here right there.
Okay.
So I can use the file open dialog or import to bring it in, or I can just do a simple drag and drop. So from the File Explorer in Windows, I can just drag it, and then I can put the file in to VisualCADCAM's window. And it'll prompt me with this message saying that the file is too large to be in inch units part. Do you want the part to be in millimeter units? So would you know if the part was modeled and saved in inches or millimeters?
It was in millimeters.
It was in millimeters. So I'm going to select, do you want to change the model units to metric? I'm going to click yes, and this automatically scales the units to millimeters and brings it in. So there's your DXF file, which is translated successfully into VisualCADCAM. If you go to Analyze and select Part Info, which gives you the overall extent, the length, and the width. Since it's a 2D drawing, there's no thickness to it or depth to it. So you can see the length shows 428.625, and then you have the distance, the width on the y-axis is 185.737. Now, if you'd like to work in millimeters, we can just continue the way it is. If you'd like to switch to inches, we can scale it automatically and switch it to inches as well. What would be your preferred units for operating this file?
I mostly work in millimeters.
Okay.
Because it's just easier to understand for me. But
okay. Yeah. We can work with millimeters too, that's fine. Okay, now once you have the part loaded in here, you'll see that by default the CAM interface, the machining interface appears over here on the left pane in VisualCAM. So you can go to the VisualCAM menu, and by default it's selected as mill. Mill module allows you to program 2 to 5 axis. We have 5 different configurations in the mill module. We have Express, we have Standard, we have Expert, Professional, and Premium. The interface, what you're looking at right now, is for the full-blown premium configuration, but as we go through the demo, I can show you what's available in the Express versus, we can do a comparison between Express and the next configuration to see the differences and, what you would be getting in Express and what would you be benefiting out of if you have plans of considering one of the other configurations as well. Okay?
Okay. Yeah.
All right. So once you have the file imported, the first thing I would do is make sure that the part is in the correct units, the dimensions are right, and also the orientation looks right. So as you take a look at the part, looking down from the top view, is the part oriented correctly to fit the work envelope of your machine tool. So as you can see, the distance on the x-axis here, the part is, the longer edge is parallel to the x-axis and the shorter edge is parallel to the y. So do you have the similar type of work envelope on your machine? Or if this part needs to be rotated so that the longer edge is parallel to the y-axis.
So this is the way my machine is set up, X and Y.
Okay.
Like
okay. And this part can fit into the work envelope of the machine tool. Is that correct?
Yeah.
Okay. Perfect. Okay, so next step is we want to go ahead and define the machining process. So by default, the Express configuration has it set to 3-axis for both 2 and 3-axis machining, so you won't have to make any changes in here. In the higher configuration, starting with Expert, you'll have access to 4-axis. The Pro and Premium also includes 5-axis machining. So you just leave it as 3-axis. The next step is you want to make your selection for the post processor in here. And right out of the box, you have post processors for over like 300 plus different posts listed in there, so which covers a wide range of machine tools that are out there. And you can find one that's for the X-Carve machine down the list in here. You will see that there's a post for X-Carve CNC right over here.
Oh,
It uses the
awesome.
Gerbil controller. You can select that, and you can set the file extension. It could be NC, CNC, or whatever the extension is. And the post can also be edited and customized if ever you need any changes to be put on it. You can modify it here. So you can see that the post is currently set for inch units. If you want the post to be output in millimeters, we can switch it to metric units and post-process it as well. So it is pretty easy to switch the units in the post-processor. So you could still be programming the part, designing the part, and programming it in millimeters, but when you post it, it'll scale the output to inches if the post is set to inch units.
Okay.
All right, so we have the post set up in here. You can see that the information is automatically updated in the machining job. The next step is to define your workpiece, the stock material. So the express configuration includes box and part box stock. So as you pick box stock, it automatically computes the overall extents of your drawing that you have in here and gives you the length, width, and then you can specify a height or thickness for it here. What would be the material thickness you're going to be starting with?
18 or 19.2 millimeters.
19.2 millimeters. I'm going to put the stock thickness in here right there, pick OK to accept it, and now when I click on show stock, it actually displays the stock right on top of the part, as you can see right there. I'm just rotating the view by holding down the right mouse button, and you can see that the stock is defined, and it automatically computes the bounding extents of the drawing that you have.
Nice.
Now the next step is we want to align it. So we want to make sure that the stock and the part are aligned correctly. So we go to align and pick align stock. So typically you'd want to have the stock, top of the stock, flushed with the top of the part or the top of the drawing, so that we say Z alignment to the top, and the XY could be centered. Now if you had excessive stock being left, you would have left additional material on the side. Since the stock is now defined to the exact size of the part itself, the extents of the part in X and Y, you're seeing that the edge of the part and the edge of the stock are lined up perfectly. Now, would you like to start with a larger piece of blank in X and Y, or is this the size you want to go with?
So the way it's actually done, you can see that it's slightly offset. The part is offset from the zero by like a half an inch each direction. So there is material. There is like a half an inch of material on each side.
Okay.
But I don't know that matters for this.
Okay. So yes, we can do this certainly. So what I could do is go over to the part box stock definition and say I can put in a half an inch offset in each direction. So I can specify half an inch would be about, is it 12.7 millimeters? Is that right?
Yeah, something like that.
Okay.
It may not be a half an inch. I'm trying to remember.
Okay.
It's been a while since I built this. But,
all right. So one of the easier way for us to determine is if we go to Analyze and click on Part Information, it gives you the lower left corner in here. You can see it's the XY corner is 14.288. So it's basically 14.288 millimeters offset from the origin.
Okay. So then, yeah.
Okay.
That's what we want.
So we could go back and do a part box stock, and we can put in 14.288 in X and 14.288 in Y, and the Z would be the height of the stock material that we can put in was 19.2. So in this particular step, you'll see that it automatically creates the stock where you extended it to the origin. The other way to do it is you can actually take this geometry and offset it out towards this origin, so that, and then you can just do a stock with that as well. So there's several different ways how we can do it. Okay? So
cool.
now the zero is also flush to the top and then the southwest corner, as you can see right there. So in this particular step, you don't have to set the zero because you already have the drawing and the part designed, and you had it already designed at the origin. So if you did not and you wanted to move it around, you can always move the origin around. If you want to pick one of the other corners, we can automatically perform this translation in here in X and Y and Z.
Okay.
So, but for now, I'm just going to leave it the way it is. So I can skip that step. All right. So we got the the machine set up. We have the stock defined, so you can see that we are working our way from left to right as you work through these groups in here. So in the next step, we are now ready to define some tools and program toolpaths in here. Now you can also pick the material that you're going to be working with. If you're going to be cutting aluminum or wax or plastic or wood or whatever material type you're going to be cutting, you can select that from the list in here. And you can also add additional material types. Let's say, for example, you're picking wood. You can specify the texture too, and In the Express configuration, we do not simulate with the texture, but in the standard configuration, we can do a simulation with the texture as well.
Okay.
Okay. Now, the next thing we can do is define tools. So there are different tool types available to you. In the standard and above configurations, you have access to all of these tool types. With the Express, you'll have ball mill, flat mill, you'll have V-mills, you have drill bits, and also, I believe, the corner radius tool. So we can actually go up to our help section in here, and if you go to welcome, and you can click on configurations, it actually lists the tool types that are offered in each and every configuration. So you can see the Express includes ball mills, flat mills, corner radius V mills, and also standard drill. The standard offers all the other tools in here.
Okay.
Okay, so the interface is basically just skimmed down with the tool types in here. So we can define tools of different sizes and dimensions in here based on what you have available. You can also define your material for the tool number. You can also set your feet and speeds. We also have a built-in calculator which can help you establish feet and speeds based on the material, tool material, and then the surface speed and the feet per tooth, which is the property of the cutting tool. And you can establish each of these parameters in here.
Are there like any like defined, so there's a lot of parameters in there, right? And I'm just wondering if I can buy a specific brand or something like that of a flat end mill and a part by part number or something like that, would you guys have those parameters already set where it would just import into that tool?
We do not have a catalog of tools where you can just put in the catalog, the item number to fill in the properties, but you know,
Okay.
from the place where you source your tools, they will have some recommendations on what you can go with for spindle speed and RPM based on the material you're working with, and you can actually just put this in here and then save those tools to your library, so the next time you select a tool, it'll automatically have that information in there.
Okay.
All right. Okay, so now we are ready to program some toolpaths, and as you mentioned, you would like to pocket out the material between these areas in here, right? So what I'm going to do is, since these are just lines and arcs or splines or whatever geometries they are, I'm going to just join them all together. So I can just window select all of these drawings in here, the curves, and I can go into the curve modeling tab, and I can use this command called merge, and then right click or press enter. So it actually chains all of them into a closed geometry as you see it right here.
Awesome.
Okay, so it just makes your selection process a lot easier for your programming of your toolpaths. So the first step is you want to clear the material out, between these areas in here, right? So you want to hog all the material out that are in here. Am I correct?
Exactly.
Okay.
Yes.
Now, would you like the cutter to go past this edge, or you want the cutter to completely stay inside this rectangular boundary?
It needs to stay inside of that boundary.
Okay, perfect. So what we do is a method called pocket machining or pocketing. So under 2-axis, with the Express configuration, you have facing, pocketing, profiling, V-carving, and engraving. Again, if you go over to the help section in here, you go down to configurations, you click on 2.5-axis machining, it'll tell you what operation types are available in here.
Okay.
Okay, so first step is we want to do a pocket machining. So we'll pick pocketing, and now it brings up this interface where you can select the geometries for pocketing. So I'm going to click select curve edge regions. I can window select, or I can even individually select these geometries in here. So these are the areas I would like to pocket. So the system will automatically know the topology, what you selected based on what is outside and what is inside. So which means that if you select these, it knows that the cutter will never, violate these boundaries, which means the cutter it'll only be machining between these two areas.
Okay.
Now I can also select the inside boundaries in here. I can pick all of them. So the cutter will try to do between this, and then it'll figure out what is inside, what is outside. So if you want to just drag a window, you can also window select each of these drawings in here. So there are several different ways how you can pick. So I'm just showing you the different techniques in here. You can either individually select them, or you can drag a window to go select all of the geometries in here.
Okay. I was going to ask that. If I was going to have to create a pocket for every single one, because I did want to cut inside of the S and inside of all of those as well. All right, cool. So it can recognize
outside and inside automatically.
Outside and inside.
On a pocket, yes. It knows the topology. Now you can pick a tool, whatever type of tool that you like to pick for it. So we have different tool types I have already loaded from a library, but you can define your own tools and build your own tool libraries.
Okay.
What type of tool would you like to define?
I'm working first for the clearing or the roughing pass. It's a 1/4 inch flat mill.
Okay. So you want to use a 1/4 inch flat mill in here. So what I'm going to do is a 1/4 inch would be equivalent as a 6.35 millimeter. I have one in the library in here. So I'm just going to use that. And I can change my tool number to 1. So I just had it set to 2 in here. I'm just going to go with that for now. You can see that the feeds and speeds are being loaded from the tool. The clearance is set to automatic. In the cut parameters, with the express configuration, you'll have offset and linear cut patterns. So we can, since you wanted to raster back and forth based on our earlier conversation, I'm just going to set the linear cut pattern in here. I'll also add a cleanup pass, so it'll actually go around the islands and do like a finish pass around it between each of the islands. And you can specify a tolerance for your roughing process. You can set the stock to leave if you want to leave some material around the exterior, the edges of the part, like around the islands and the side walls, you can specify it. Or if you want to finish it right to the edge, you can put the stock to leave as 0. And then the next step is the cut levels. This is where you specify how deep you want it to cut. Would you be able to provide me how deep you like to cut?
4 millimeters.
Okay, 4 millimeters. And would you like to do it in multiple steps? Take it down in like 2 steps of 2 millimeter each, or you just want to do it in 1 step of 4 millimeter?
2 steps.
Okay, so I'll
2 millimeters each. Yeah.
And then you can specify your entry and exit. Since you're doing a pocketing, you can ramp into the pocket where you can specify the parameters like your ramp angle, ramp height. It'll ramp along the path. I can specify those parameters and I can apply those ramp for each level. So there's 2 levels. You can do it for each level. And you can also specify fitting of arcs to your tool paths. So basically it'll try to fit true arcs in here. You can also do a sorting in the higher configurations. In the Express, the sorting is not available. So once you specify these parameters, you can hit generate, and this will automatically analyze your geometry and compute your toolpath.
Will this automatically take into consideration the V-bit toolpath that's going to come up next, or do I have to set up those parameters properly so that it doesn't clear out too much material right up? So like I need some material to be able to do the V-bit next to that, all those edges. Does that make sense?
Yes, makes sense. So for that, what you need to do is a method called V-carve roughing instead of a pocket machining, 2-axis pocketing. So the V-carve roughing is what you're looking for. Now the pocketing operation, it actually goes right up to the edge. It doesn't account for the draft on the finishing tool. So I'm going to go ahead and do what is called a simulate to end in here. So the simulation, what you're going to be seeing here is the advanced simulation module, which is available in the right from our standard configuration. You have a finer simulation model. With the Express, you do have a simulation, which is called our homegrown voxel simulation model in here. So I'm going to run the simulation so you can actually see it, which is with the finer simulation. And then you also have the coarser simulation, which comes with our Express configuration. It's called the voxel model simulation. Now this is basically, you can see it's going right to the edge. It's not accounting or compensating for any of the draft angle for the finishing tool, right?
Yeah.
Okay, now if you wanted to account for the draft angle for the V-bit, what we need to do is a method called V-carve roughing. So if you go into 2-axis methods, V-carve roughing is a technique that we would use. And then I can still use a flat mill. Now the interface looks very similar to your pocketing operation, but in addition to the parameters that you put in, you'll also have to put in the taper angle of the finishing tool. So if you're going to be using a V-bit, if the half angle or the include angle is 30 degrees, you put in 30, or if the include angle is 45, you put in 45. What is the V-bit that you plan to use for it?
It's a 60 degree.
So that would be 30 would be the include angle, right? So the total angle is 60, so the half angle, so if you go into your, so you put in the half angle, which is the include angle. Now this method, which is called the V-carve roughing, is available starting with our standard configuration. So you need to have standard or above to be able to do V-carve roughing. So I'm going to pick the same cutting conditions in here, specify the cut levels. We'll use the 4 millimeter depth. We can go in 2 millimeter steps in here. You can specify the entry and exit. Very similar. You can see the interface looks very similar to what we did in the pocketing, except this automatically accounts for the finishing tool's taper angle. So now I'm going to go ahead and generate this toolpath in here, and it's going to compute the toolpath, and it'll automatically create a draft. Basically it'll create like a stepped area, so it accounts for the finishing tool, which means it'll take into account the draft angle that you put in, the taper angle that you put in for the finishing tool. So when the pocketing, the roughing operation computes the offset, it knows that it needs to account for the finishing tool's taper angle automatically. So that's what the VCarve roughing operation does for you. And this VCarve roughing comes right from the standard configuration. It is not included in the Express. It comes only from the standard configuration of our product.
Okay.
Would you have any questions so far?
So I'm not sure what the cost of Express versus standard is, but let's say it's a pretty significant difference. Is there a way with the Express that I can maybe say offset, don't carve all the way up to that line? Can I offset the roughing pass up to, I don't know, whatever that, probably a half a millimeter or a millimeter or something like that away from everything?
Yeah, the way
I can do my VCarve afterwards.
Okay, I see what you're saying. So the way you could do it, accomplish some of those would be in the pocketing operation. You have what is called the stock to leave. The stock is basically a side stock or a wall stock, so you can specify to stay away from the sidewall by a half a millimeter or whatever distance that you want to put in here. So if you put in a stock of let's say 0.5, it's going to basically go ahead and stay away by 0.5 millimeters from that particular from both interior and the exterior edges of the part. So that's what the pocketing operation, how you can do it to leave stock. Now if you take a look at the VCarve operation in here, you can see that it is leaving that material right there, right? It is doing that. And then here we've also added I forgot to include the cleanup pass. I can do a cleanup pass as well. So that'll also basically go around. So if I didn't do a cleanup pass, you can see it's not connecting or adding a finish pass around this here. So I can go back, edit the V-carving operation, go ahead and say I want to add a cleanup pass, select that, and then I'm just going to right click and regenerate the tool path. So now it'll basically add a path around it here to clean it up. So the V-carve roughing does this for you automatically. And yes, we can certainly get you all the information about, the pricing for each of the configurations. All of this information, you can actually find it on our website. You go to mexop.com, and then right on the top of the page, you can click on eStore, and you'll get pricing information for each of our product configurations.
Okay, cool.
Okay, so now on the pocketing, if you want to change it, you can double click on this here, and you can specify to leave some stock. So I could go into the cut parameters and say I want to leave about half a millimeter stock, right? And then I can go back and generate it. So if you measure this distance, if it's about half a millimeter, you just put that in there. I'm not sure what exactly, because we can compute it in the VCarve roughing based on the tool's draft angle, because as you go cut deeper, the offset keeps increasing. That's the beauty of V-carving, is it can automatically account for that. So the first level, 2 millimeter, the offset is going to be different compared to the next level.
Right.
So that is automatically computed in the V-carving operation. So as you can see here, I'm using what is called a multi-threading, which means each operation can be generated on its own thread or core. So if you have a multi-core processor, you can have multiple operations being generated simultaneously.
Nice.
And with the standard, you have a lot more options available. You can do slot machining. You can do 2-axis roughing. There's more options, more choices. Now you can see that the V-carve roughing just got done, and it did add the cleanup pass. So if you take a look at it, there's 2 levels in here, right? So if I go to the top view, you can see that the first level is closer to the geometry. If you look at the levels, and the next level is offset. You see the difference right there, sir?
Yeah.
So it automatically accounts for that. So if I go ahead and run a verification in here, I go to the Simulate tab, I can do play. You can see that's the first level, and then you can see the second level, it automatically accounts for that, so you get a stair step right there.
Nice.
So that's V-carve roughing, which is available to you in the standard configuration and above. Now if you just want to do the pocketing, you can see that in the pocket operation, you're just manually accounting for some stock to leave.
Yeah.
So the geometry is right here, over here, and then you're specified to leave some stock. So, okay, so now I'm going to go back and just put the V-carving on the top right here. Now, once we are through with this operation, the next thing we would like to do is program a V-carving operation with a V-bit. So we want to select V-carving. And since I had the operation, machining operation pre-selected, it automatically used the same machining geometries for the next one.
Nice.
So I'm going to go to the tool, and I have a tool here. So the taper angle, the included angle is 30 degrees. So if this included angle is 30, the total taper would be 60.
Right.
You can define the tool diameter where the taper ends. You can specify the shoulder length. So do you happen to have the information about the tool diameter on the V-bit that you're going to be using?
Those things I don't have.
Okay. We'll just go with the standard numbers in here. I'll just go with a 1/2 inch diameter over here.
Mm-hmm.
Okay. Now, I'm going to have this tool selected in here, the 60-degree total angle, which is 30 is the include angle. And then I'm going to go in and set my feeds and speeds, clearance. The workflow is very similar. In the cutting parameters, you'd want to now set how deep you want to go, which is going to be 4 millimeters again. And we can break it up into multiple steps. You can even go like 1 millimeter steps. You know, we don't have to match the same number as we did for the roughing. We can do it in multiple steps. And now I'm going to choose the side to be cut as inside, meaning inside of the outermost boundary, and it'll be the outer of the outside of the interior. So it automatically knows the topology of the geometry as well.
Okay.
Now I'm going to pick generate. So in this particular process, it's going to create a V-carving operation. So the V-carving operation is available in all configurations right from Express. So this is a new operation that was introduced, V-carving in the Express configuration, starting with our version 2018. So the V-carving operation has been generated, and as you can tell here, you can see it is following the geometry. It automatically checks for any interference with the adjacent geometries. As you can see over here, it checks for those interferences automatically in these areas, as you can notice it right there, right? So that's the beauty of V-carving. It automatically handles that. So let me go ahead and simulate this. I can also do a save or save as, and I can pick the folder where I would like to put this file in. So I'm just going to go back and save it in the same folder where we had the drawing pulled up from. So we had the operation simulated for the V-carve roughing, and now I'm going to go ahead and simulate the V-carving operation in here. I can even slow down the simulation. As you can see, you have precise control on how fast or how slow you want to run the simulation.
Nice.
So it is running the simulation. Now this is the advanced simulation what you're looking at, which comes included from our standard configuration. I will be able to show you the simulation that's available in our Express as well in just a moment.
Okay, I will submit a license request on her behalf, and so just please wait for an email from license@Microsoft.
So you can always do a pause and then pick simulate to end, which will also run through the simulation to the end. Okay?
Okay.
So once you have these operations programmed, you could go back in here and take a look at your estimated time. So if I right-click and go to information, it'll tell us how long it's going to take to cut it. So you can see that the first operation, the V-carve roughing with a 600 millimeters per minute feed rate, it's going to be under 2 hours, and then the V-carving is a little over an hour. Now the last operation, the pocketing, it also estimated that to be 2 hours and 12 minutes, right? So now if I want to suppress one of these operations, I can right-click and suppress, because we were comparing the two operations in here, right? Now I can right-click and select post, and it's going to post just the first two operations in here. I can specify the folder to post it to, and it's going to write out the G-code, and the G-code will typically show up in a notepad, or you can point it to any editor of your choice. So there's your code. You can see that the code is output in inch units. G20 represents inch, and this is now ready to be transferred out to your CNC machine tool.
Excellent.
Now, with our standard configuration, you can also do what is called a setup sheet. So we can generate shop documentation, and this can actually create a nice little HTML report which provides you the information about the tools, the operation, the stock information. So you can generate this, and then this is very useful. If you need to have the operator in the shop floor get prepared for the machining's job, he has information about the stock dimensions, as you can see right here, the stock material, what I chose, the type of tools being used in the two operations.
Very cool.
Okay. Any questions so far?
No, I think you've kind of hit how I want to do everything.
Okay. Now here's what I'm going to do is I'm going to go ahead and show you the Express configuration in here. So I'm going to go ahead and basically just reorder the operations here. We have these two operations. I'll save this out. Now, I can go ahead and switch to Express configuration. So I just had to release my license and then go back and run it in Express mode. So I'm going to do that here. Now, before I switch over, I wanted to point out a couple of nice features that you see in the standard is you can take all of these operations that you program and save them into a knowledge base. So when you have parts that are similar, have a similar workflow, you can actually just load the knowledge base. Knowledge base is basically the template of all the machining operations that you programmed. So you can basically load the knowledge base. It'll have all the settings, the tool that you specified, the cut parameters, the cut conditions, the depth. All of the information will be saved in the knowledge base. Only the geometry and the actual generated toolpath are not saved in the knowledge base, but everything else. So it makes it easier when you have family of parts, a class of parts that require a similar workflow. So you don't have to go through the process of recreating those operations over and over again. Now, there's one thing you can do further. One additional step is, let's say I want to go ahead and save this to a knowledge base in here. I'm going to put it in here. Now, we can go to this tab called Knowledge Bases, and we can actually automate the selection of geometry. So I'm going to go ahead and load the knowledge base in here, and then I'm going to go ahead and select, I want to apply some selection rules. So I can basically set up rules in here to automatically select geometries based on layer. I can say I want to pick geometries on each of that are in each of these layers. So when you load a knowledge base, it can automatically also select geometries. So you might have certain geometries on certain layers, and we can make the selection of geometries. Also, we can automate the workflow in here. So if I go back in here, in this example, I'm just going to pick all of these in here just for the purpose of our demonstration, and I'm going to call it with the rules on it. So now, if I go ahead and let's say I did not have any of these operations in here, I drag and drop this into it, you'll notice that it automatically picked the machining regions for us as well. So I didn't even have to go ahead and select any of those. So if I go back and load my knowledge base in here, I can say load knowledge base, the one with the rules on it. You can see the one with the rules are right here. You'll notice that it automatically also added the machining regions to the operation.
Nice.
So that's the level of automation we can accomplish in here.